Okay, so I have wanted to showcase how I have debugged problem, maybe not a problem per se, but like how TypeScript actually evaluates something like that. So we have an indexed access here, um, and it's indexed by this type here. So I don't know, like I would call it an index type, and there's an object type within that indexed access. So how can I do that, and how I have approached that? So one of the things that I start with, I go to TypeScript repository. I execute gulp tsc to build the thing, to like build from sources. It's not necessary, but what I have found lately that it's quite nice because this will actually preserve inline comments and stuff like that. So the output will be more readable while debugging. One of the things that we might also want to do here is to find this debug mode, and in yeah, where is that? Yeah, it's in sysTS, and I just replaced that to true. I guess like you could technically run the process with some of those environment variables or a flag, but I don't want to influence anything else, and I'm not sure if that's like used anywhere else too. I just want to add some quite helpful debugging methods to objects in within the TypeScript. We'll see how we can utilize that in the process later. So yeah, I just override with this debug mode true. I build the TypeScript compiler. I won't execute it now. Let's not waste time. Later on, it's available in, I believe, local tsc.js, or maybe build. So maybe let's find it in, okay, so like it's built local, and we have this tsc.js here. So we can just grab it, copy paste, or rather copy it from here, and just go to your node modules and replace the content of your TSC here with that. I have already done that, so yeah. Yeah, that's pretty much all that you have to do, or rather like how I prepare for that. And later one of the things that I have found useful is that sometimes you might want to kind of like evaluate the type, or like export its result or something. Like in here, of course, it's already done, but sometimes it might matter, and TypeScript tries to, I think that's, I'm not completely sure, but I think like TypeScript tries to be sometimes lazy. So if it doesn't need to actually give you a result or something, it might not compute a thing. So it's kind of like better to force it to actually compute it sometimes. But yeah, we already kind of like compute it and export that A type from this module, so it should be fine. So I can execute something like that. So it's replay node. I give it a path to local TSC. I just pointed to a file to like scope this run, and when I pointed to a file, then it kind of ignores TSC config, which is annoying. But so I need to provide it with some flags to the CLI itself. So I usually just call it with no emit, skip lib check, and skip default lib check. It's mostly because like it will narrow the scope of the work that TypeScript does. So it's easier to navigate a replay recording. So I just call that command, and then I upload the recording with replay view latest, which opens me which opens this uploaded recording immediately, and we can start playing with it. This is the one I've used yesterday to debug the problem. So yeah, like I already knew that I can search for like check source element. I've added a breakpoint there at this function probably. Yeah, the problem is it has quite a lot of hits. So we need to narrow it down. So when I was here, stopped at some random call really, I've just climbed the call stack in a way. So we have that call stack here, roughly. And yeah, I grabbed check source file. Okay, this is still, that is useful, but I need to go to like check source file worker. And in here, I was actually then like stopped here. So maybe we can even go here. And I was like within this check source element, somewhere deep in it, but I already knew that I'm not interested in that call in a way. I need to go to the very last statement of this file because this is the very last statement in this file. And yeah, I could probably narrow it down, but it was just a dummy example that I copy pasted from TS Toolbelt just to get myself quickly going. And I wanted to ensure that it's pretty like abstract with generics and all of that. So it made sense to just reuse some existing code and not write something from scratch. So while being here, we can go back in time and we can inspect that these statements have like 10 elements. Oh, it is sounded a little bit slowish. Sorry. Yeah, so we can check here that it has 10 elements, and we are interested in the very last one. So yeah, like right now it's a little bit tedious because I need to go to the very last one, but this function is executed a lot of times because like it's for each, it's super generic. And it might have like thousands of calls to that. It's still indexing, loading the number of hits. So yeah, don't bother with that. But we can like just, iterate over this loop and just go to the very last iteration of that. Let's click a couple of times and let's check now like so like it has a lot of hits as we can see here, so it's not useful to put any breakpoint here, but we can just, since we only have like 10 statements, it will take a little bit of time, and like it's doable to get ourselves to the very last one. So yeah, we are at the 5th one, so let's continue. So like we are at the 6th, probably like 7th, and let's recheck last time, it's like 8th. Yeah, and here we should be at the very last one. Yeah, 9th. So let's go to that. Yeah, and we need to just dig deeper. Check type alias declaration. Okay, looks okay. We basically want to go to the source element and to like its instantiation, like yeah, too far. So here, okay, again, it's very like recursive algorithm, so it will descend into this tree that your type forms, and it might, like, for example, type check its type arguments first, and only then, like when this is computed, go to the type alias declaration and all of that. So so we have to skip over some fluff that we are not really interested in. And if you if you get more familiar with the code base, you just might recognize some keywords that are useful for you, for your case, and you might be able to navigate this this more quickly. But until you do, I find it useful to to just go from the top and just descend into the whole function, the whole checking process, because it's easier. You don't need to know any kind of vocabulary or any implementation details. You just can observe how it processes over your types, your file, and stuff. So I often skip over some things to just check what's the result. It's quite beautiful because we can actually get back in time with replay. And in here, I can show how our debug mode comes helpful, because it makes some objects in the TypeScript compiler to have debugging methods. So like a type has this debug _ debug type to string, and if we evaluate that, it will yield some readable result to us, which is really helpful, because reasoning and reading the type itself, well, yeah, that's quite complex. And while we might be able to read from here that it's some kind of a type with A and B members, so we might be able to map this in our minds to what we expect here, but it's much more bigger effort, and it's not always that easy. If you start dealing with conditional types and stuff like that, it might be hard to especially to quickly read through this. So this debug type to string is just immensely useful. So you can somewhat see that it's already our result. So definitely we are interested in that call here, because that result is being computed here. So we need to get that computation. And yeah, let's continue here. Symbol, yeah, so let's go to computation of the type. Okay, sorry, I need to go back. Yeah. Yeah, this scrubber here is quite useful. We can kind of grab it and just quickly progress through the frame and see how it went through this particular function. Okay, get type alias instantiation looks roughly interesting. Yes, so most likely we're interested in this call. Yeah, so I can press my, as we can see here, it's a plus icon here, so I can add a lock point here, and once I add it, this get type alias instantiation appears on the timeline in the console here, and it's all the hits to that function are already annotated here, and you can edit that. So so you could, for example, call stuff like this here and have everything console logged out to your console on the right for every invocation. So it also might help you to navigate the thing. But I'm not interested in that now, so I just remove that. And I can hold my command or control, I suppose, in Windows. Then this icon changes to this arrow, and if I click it, I can just continue to here. So why that was important, because I didn't really want to step into type arguments from type reference node, and also into get type arguments for alias symbol, because I already suspected that it's not that useful at this point in time for what I'm looking for. So I didn't want to descend into those. So I have just more quickly stepped over those by going to a function that receives those returns already computed here. So yeah, instantiate type with alias. This also looks promising, and we have a very similar problem here that we have some unrelated calls here. So I can just go here and so continue to here, and we can recheck after recheck if I'm still at the right place. Because when we skip over stuff in debugger, we might often go too far. So it's for me it's useful to just recheck if I didn't accidentally do that, because if I did, then perhaps I'm already too deep in the rabbit hole and I should just backtrack. That's already interesting, because this one, this one, as we can see, like this instantiate type worker checks if a type has a particular flag on it. Types are annotated with those bits that help the compiler to differentiate between them and to just dispatch logic to specific branches of the code. So if we hit this indexed access, it's probably already what we are looking for, unless it's one of the deeper ones or something. But yeah, so we can for example just copy paste that. I expect this to return a type, so just check that. Yeah, it's already like our result. It's expected to me. We can also so like the result of this is the final type that we are looking for, in a way. So like, how is it really computed? So from here we can see that get index access type receives a couple of arguments, and two of them are already like instantiations of particular things. So if we grab this type object type and just log it and do the same with index type, yeah. So we can see that that it's still not instantiated, but that's this object type, and that's this kind of like indexer in what we index that object type with. That's this depth like type variable, or other type parameter in here, I guess. So yeah, like if this get indexed access type already receives an instantiation of this object type, then we can try evaluating that to see what happens. But I already have suspected what might happen. And in here we might see that it already has both, like all of the branches pre-computed. So like every property got computed here, and only later we tried to get indexed access type from that based on instantiated index type, which we can also instantiate here to just compare, and it should be flat, I think. Yeah, so it's flat, a string type, literal string type. So yeah, that's how like I've got to it. It wasn't that hard, but there is some initial familiarity barrier, and that code base is definitely quite scary, and not every case might be as simple. to like narrow down why something happens and how TypeScript actually goes over it. This was pretty easy. And like, for example, instantiation might be way easier. Like going through instantiation might be way easier because it's basically computing stuff with by supplying some arguments and stuff like that. Than for example going through the inference algorithm that is at least I feel like it's way more involved. So yeah, I hope that you have enjoyed that.